Continuing with section 6 of chapter 3 in the normal probability, exercise 24 on page 96. The demand for a new product is estimated to be normally distributed with mu equals 200 and sigma, or the standard deviation, is equal to 40. Let x be the number of units demanded and find the following probabilities. So what we have is a continuous random variable x that has a normal distribution and its mean is 200. Question A. What is the probability that x is going to be between 180 and 220? So in our graph, we have 200 here. 180 is obviously less than 200. 220 is also greater, 220 is greater than 200. So the question is, what is the probability that x is between those two numbers? Well, the probability is equal to that area under the curve. But since we don't have normal distribution tables with specific values that can be infinite possibilities, we always convert our problem to the standard normal. So let's convert first 180 using the z-score formula, x minus mu divided by sigma. Z is equal to 180 minus mu, which is the mean, divided by sigma, which is 40. Sigma is here, previously given. So that is equal to minus 20 over 40. And if you notice, minus 20 over 40 is just minus 0.5. And what is my z-value for 220? Well, 220 minus 200 divided by 40 equals 20 positive divided by 40. So both numbers are the same distance from the mean in terms of standard deviations. So in terms of z values, or in terms of, z area, what we're looking for in my z distribution, I have 0 here, 0.5 here, minus 0.5 here. That's the area that we're looking for. Well, first we look at the table with positive values. It'll be enough, but if you want, we can use both the positive and negative sides. But by symmetry, if you use symmetry, you don't need to use a negative. All right, what is the cumulative area that corresponds to the z-value of 0.5? Again, we go to the first column here, go down to 0.5, which is right here, and the very next value is 0.6915. So 0.6915 is the area to the left of 0.5. All the area. From 0.5 all the way to at least minus 3 is all the way to the extreme smallest value here. Okay, and using the negative, you can find, actually this is too far to the left. We'll assume that this is minus 0.5. What is the area to the left of minus 0.5? which is the other number given. Well, like I said before, you can use the positive and use symmetry afterwards, or you can just directly use the negative, which is a little easier. Let's look at the negatives. The negative starts with the the largest possible negative, which is -3. And then it goes down here to minus 0.5, which is right here. The cumulative area to the left of minus 0.5 is 0.3085. Okay, 0.3085. So this area here is 0.3085. So now we're ready to calculate the area between 0.5 and minus 0.5. It is very simple. The area to the left of minus 0.5 minus the area to the left of minus 0.5 should be equal to the area between those two numbers. You can use that in general for any two numbers. The area between two numbers is the area to the left of the largest number, and then you subtract the area to the left of the smallest number. So it'll be 0.6195 minus 0.3085. Okay, so this will be 0, 1, 1, 3, 0.3110. So that is the area between 0.5 and minus 0.5. So the probability that the values are between, going back to my original question, the probability that the x values are between 180 and 220 is equal to what I found here at the bottom, 0.3110. So this is 0.3110 or 31.1%. The next question says, what is the probability that x is greater or equal to 250? We just convert again 250 to a z-value. Remember that the mean is 200 and the standard deviation is 40. So this is 50 over 40, 5 over 4, which is 125, I believe. Yes. Okay. 1.25. So in terms of the z, using a graph or using the standard normal, is a 0. 125 obviously is to the right of 0. Greater than 250 is the same as greater than 125. So in our table, we just have to look for the area that is cumulative, which is directly given by the table, and then subtract that area from 1, and that should give us this number here. So let's look at the positive side of the standard normal. Let's look for 125 on the z values. Okay, we stop at 1.2 and then look for 0.05 here on top. 0.05 is right here, that column. Okay, so across 1.2 until we find 1.25, which is a number that happens to be highlighted in your table. That is 0.8944. Okay, so this is 0.8944. Please do not confuse the area values with the z-value. The z-values are measured along this line. The areas are values under the curve. These are probabilities or areas under the curve. The maximum value under the curve is 1.0, which is the entire area. All right. Since this value is 0.8944, what would be this value? Well, this value is just 1 minus 0.8944. Okay, and that value should be 0.1056. Okay, so the probability is 10.56%, or the area is 0.1056. That was question B. Question C, what is the probability that x is less or equal to 100? Again, we need to convert the 100 to z. 100 minus 200 divided by 40 minus 100 divided by 40. Okay, cancel the zeros. And half 10 is 5, half 4 is 2, so this is minus 5 over 2. It's the same as minus 5 over 2, right? And that is equal to minus 2.5. Okay, so the question is less equal to 100. Well, that is equivalent question to find the area to the left of minus 2.5. And again, we can directly look on the negative side. Minus 2.5 is 0.0062 here. 0.0062. So this value is 0.0062. It is directly given by the negative side of the standard normal distribution. I have told you that you can use the positive, and we can see it here. How can we use the positive side? Well, if you look at 2.5 positive, the cumulative area is 0.9938. 2.5, the area cumulative is 0.9938. So on the positive side, this is 0.9938. Well, the area to the right of 2.5 must be exactly equal to that area to the left of minus 2.5 by symmetry. And how do we find this? Well, just 1 minus 0.9938. Since 1 is all the area, subtract 0.9938, so you will get this area. And the areas have, if you do that, you should verify that it is 0.0062, which is the same. Finally, the last question is, what is the probability? Let me flip this page. I have a blurry image here. All right, here it is. What is the probability that x is going to be between 225 and 250? I told you before that when you have these areas between two numbers, you just subtract the two cumulative areas. So convert this to z. 225 minus 200 divided by 40. That is equal to 25 divided by 40. And what is 250? 250 minus 200 divided by 40. That is 50 divided by 40. We already know that 50 divided by 40 is 125. We calculated that before. And 25 divided by 40 is 0.63. Okay, this is 5. So those two are positive values of z. So in my z distribution, what I have is 0.63 here and 125 here. In my area of interest is this, which is equivalent to, in my original distribution, where I have 200 here, this will be 225, and maybe here we have a 250. So we're looking for that area. That area must be the same as this area here, using the standard normal. Well, what are the cumulative areas using our table? Well, we already did the 125. We can review it. 1.2 and then 5. Move to the right until you are under 0.05. That's 0.8944. And what is the area that corresponds to 0.63? The cumulative area of 0.63. Just go to 0.6 here. Okay, 0.6. And then you move to the right until you are under 0.03, which is 0.7357. So this area is 0.7357. So what is the probability that z is between 0.63 and 125, which is identical to the question that x is between 225 and 250? Well, it's simply the largest area, which is 0.8944, minus the smallest one, which is 0.7357. The area between the two is one minus the other. So it'll be 0.8944 minus, oh, I don't have enough decimals here on my, let me do it by hand, minus 0.7357. Okay, so this is 7, this is 8, this is 5, and now this is 1. Okay, let me verify this. 14, 14, 9. All right, it'll be 0.1587 or 15.87%. So that'll be the last question.